30 tons of boxcar sitting here without a locomotive. It takes a lot of work to move something like this, and usually the locomotive provides it. But would you believe that by the end of this program, I'm going to use these itty-bitty muscles to move that boxcar, and I'm going to do it with a force transformer. Not this way.
Humans were not blessed with very much strength, yet we have a yearning to move things that are very large and heavy. One way to do a lot of work is to invent complex machines that develop tremendous amounts of power. But this is very expensive and not always practical. Another way of doing work moving heavy objects is to use much simpler and more convenient devices called force transformers. A force transformer, like this jack, takes a small force, in this case provided by human muscle, and transforms it into a much larger force, able to do work like lifting a vehicle. Pulley systems can do the same thing for torque, transforming small torques into larger torques to move larger wheels. Low pressures can be significantly increased and turned into high pressures in fluid systems. And in electrical systems, transformers can take the low voltage of a device like a battery and transform it into the very high voltages needed for spark plugs. In every case, it looks as though you're getting something for nothing. More force out than was put in. Unfortunately, nature never gives us anything for nothing. If something is gained through a force transformer, then something has to be lost to keep the balance. What's really happening is that work is being done at one end of the transformer. This is the work in. Then work comes out the other end in a different form, the work out. The work out can never be greater than the work put in, but it can be in a different form. So what's changed when the force is increased? We can get a clue if we look at the definition of work. We have seen that in order to do work, you need two things: something that acts like force and some kind of movement or displacement. In the electrical system, the two ingredients are voltage and charge. Work in a mechanical system needs force and distance, and a fluid system needs pressure and volume. Work in a rotating mechanical system needs torque and angular distance. These two components of work are changed by a force transformer. In other words, if you want to increase anything on the left side of this list, you have to decrease whatever's on the right side. The same is true in reverse. So in mechanical systems, even though a small force can be transformed into a powerful one, the strong force operates over a much shorter distance. That's why the handle of the jack must be pumped so many times to lift the car a short distance. The same is true in rotating systems. A large torque is produced, but it acts over a small angular distance. Devices like pressure intensifiers increase pressure, but only at the expense of the volume. And electrical transformers step up voltage, but they dramatically reduce the current. In every case, a force transformer changes the form of the work that was put in, but it does not change the amount of work done. The work out must be the same or even less than the work in. For Rich Mortensen, force transformers are vital to his plywood industry.
This is a piece of veneer that's used in the manufacturing of plywood. Part of the process is having to run it through a dryer. That dryer runs at about 350 degrees Fahrenheit. It's about 120 feet long. It handles about 100,000 feet of this wood a day. And that dryer is run by a 20-horse motor. And to do this, we need a series of gears that enables that motor to handle that amount of wood. Now these gears are reduced. They're attached by chains, and with this 20-horse motor, we're able to handle that amount of wood.
Force transformers often help other devices do work. Chain drives, belt drives, pulleys, gears, levers, hydraulic jacks, and electric transformers all transform work into a more useful form. It doesn't matter how much the force is transformed, there's only one rule. The work out cannot be more than the work in. In fact, the work out is hardly ever equal to the work in because of losses to friction and heat within the systems. But by measuring the differences between the work out and the work in, we have yet another way of measuring efficiency. Force transformers provide an advantage for humans. The amount of advantage a transformer provides can be easily measured. This is an important consideration because it will determine the limits of the device and enable you to figure out how much work that device will provide. But that's only based on how much muscle power you start out with.
So how do we move the boxcar with muscle power? In order to do that, I'm going to use a mechanical linear force transformer. Now you would think that with a name like that, that's a very complicated device. Well, here it is. This is a mechanical linear force transformer, commonly called a lever. Now, you'll be hearing about this in our program on linear mechanical systems, but right now I'll just show you how this gives me a mechanical advantage that's powerful enough so that I can move the boxcar. In fact, I can move the boxcar with one hand.